goal is to provide data, forecasts, watches, and warnings at some key locations like the Willamette River in Portland, which is a major U.S. city that historically has seen some catastrophic floods. The better quality of the data that we have that feeds into our models, the better the forecasts are going to be, the more time that people will have to protect themselves and their property and ultimately our communities. A tool like SWOT is going to help us with making these really difficult projections and predictions for the future.
This is one of many reservoirs here in the Willamette Valley in Oregon. It is a human-made lake. It is a reservoir operated by the Army Corps of Engineers. The water managers here, they use weather prediction, they use hydrologic models, and the hope is that data like SWOT might be incorporated into those predictions to help them better understand this water body's filling and we don't want to overtop the dams, might want to start letting water out really quickly. They have to make a lot of complicated decisions. When you get a big storm event, we want to keep the community safe in the best way that we can. So how do we best manage operation of these reservoirs in terms of putting water out downstream to prevent flooding at a larger scale?
In lots of states, there are, hundreds, thousands of reservoirs, and many of those reservoirs don't have automated gauging available. And so these agencies have to kind of estimate how much water is in them and how that's changing. And with SWOT, they can just monitor that directly from space.
For us in Alaska, we have many, many rivers, and only a few of them are measured, or as we say, gauged. If we have data on when flooding is occurring or might occur, we can get crews out there to look at the bridge to make sure that the bridge and the associated roadway are still safe. If we can start collecting data on all rivers above a certain size remotely from satellites, it really opens up the amount of rivers that we can help understand what happens when they flood or how they flood. And that really improves our ability to manage our infrastructure and to design new infrastructure. That is where SWOT will really make a big difference.
One of the partners we're working with is the Department of Defense, and they're trying to fill gaps in the data that they have along the coastlines. Our military is obviously very concerned about what's happening on global scales, and they have installations across the globe. So SWOT will potentially provide an opportunity to fill in some of those gaps, allow them to make the impact assessments that they need for sea level rise in their facilities. So trying to understand and give them the information they need to plan for and then potentially adapt to these changes is really critically important.
Coastal wetlands like the Mississippi River Delta are extremely important because it acts as a buffer between us and the threatening ocean. With SWOT, because of its high spatial resolution, we'll be able to resolve water surface elevation right at the coast. So this is quite important because as sea level rises, the ocean will migrate into the land, bringing more salt into the land. So it threatens the infrastructure, the biodiversity in the wetlands along the coast. Hopefully, the types of models that we're producing can support how they decide to manage the river delta. And SWOT on its own will allow us to upscale these types of studies to the world.
Yeah, I'm really excited about the new information we'll get from SWOT and how we can start to couple it to some of the needs that we see, both at the coastal interface and also on land. I think we can potentially see some immediate impact once SWOT's launched in these communities.